Anybody has any questions? Anything on any of the homework? All right, I guess we'll just start into the new stuff then. So the stuff that we're going to be doing today, we're going to be having to kind of skip around. We're not going to be finishing the whole book. I'm just going to get the most crucial parts that we need to from it. So because we only have today and then Tuesday to present new content, and those are going to be the last 2 days we do any new content, because a week from today we'll do a review for the final exam. Oh, sorry, thank you. You guys can see my mouth moving, but nothing's happening there. I thought I unmuted myself. Thank you. So, okay, well, let me ask again then. Were there any questions? Did you guys have any questions that you wanted to go through from any of the homework that we've recently talked about? Nothing? Okay, well, so what I was saying when you couldn't hear me was that we're not going to be finishing the rest of the book out. I'm going to be kind of skipping through and just picking the most important stuff, because we only have today and Tuesday to introduce new content, because a week from today we're going to be doing a review for the final exam, and then the next week we'll be taking the final exam. So it's getting really close to the end here. So what I want you to do is I'm going to have you just pull out your notebook, not the book that we usually write in, but just a place where you can take some notes. And we'll take some notes on these things called rational exponents. We also call them fractional exponents, because rational just means that a number can be written as a fraction. So whenever you see that word rational, you should think of fraction. Okay, so they're also called fractional exponents. And so this is going to be the stuff that you'll see homework for 12.1 about these rational exponents. So remember that we talked about properties of exponents back a few modules, and with this, we're going to be using those same properties of exponents, but now our exponents are going to be fractions. So you have to keep that as part of, kind of in your mind about it. And also, the fractional exponents, I want to kind of show you where those come from. So let's start talking about this. So if you have something that says, so we've talked about some radicals. So let's say that we have this nth root of a to the n power. Whoops, a to the m power. Fix that. All right, so those are two different. N, the nth root of a to the m power. Or that can be written as the nth root of a all raised to the m power. Okay, so these mean the same thing, whether that m is inside or whether it's on the outside. And the thing that we're going to talk about is how we change these radicals into fractional exponents. That's where these fractional exponents come from. So this, if we change it to a fractional exponent, we'll have a, is the base, and then it's going to be raised to the m over n power. So notice how whatever your root is on the bottom. Okay, and so I had, some students tell me that they remember it, which way this goes, which one goes on top and which one goes on bottom, because if it's the nth root, you think about roots of a tree, right, and they're below, so that's kind of how they remembered that this is, the n needs to go on the bottom, whatever that root is, okay? And so that's what we're going to be doing first off here, is kind of just changing from one form to another, making sure you kind of get the idea of doing that, and then simplifying some of these also. Okay, so let's do a few here. So in this first example, I want you to use radical. Oops. So use radical notation to it, and then simplify, if possible. Sometimes you're not going to be able to. All right, so let's do this first one. So I'll do part A. So if I said 25 raised to the 1/2 power, right? Well, it's telling me to write it in radical notation, and that means you're going to be writing it as a root. All right, so the base, whatever the base is going to go inside. That's the 25. The 2 is our root, so it doesn't really need to be put on there. Remember, square roots, if it's a square root, we just leave that blank, but I'm going to put that 2 there just to make sure it's clear where that 2 is going. And then this 1, right, is all raised to the 1st power. And like I said, you could either have that 1 on the inside or on the outside there. Okay, and so I'm going to put it on the outside just because I'm going to show you something here. All right, and then if I was trying to simplify this, right, I take the square root of 25, so it's just important to kind of see the square root of 25 is the same thing as 25 raised to the 1/2 power, right? If it said the cubed root of 25, that would be the same thing as 25 raised to the 1/3 power, right? And so on. So it's the 4th root, 25 raised to the 1/4 power. So that's kind of what's happening here, but we can simplify this one, so we want to simplify it if we can. Square root of 25 is just 5. And then raised to that 1st power doesn't change anything for us. It's still going to be 5. Okay, so we're just changing it from one form to another and then trying to simplify that. Okay, let's look at another one. And how about this one if I said x to the 1/5 power? Okay, so what's going to go inside my root, inside my radical?
The base?
Yeah, the base.
Just x?
Yeah, just x. Right? And then what's our root going to be there?
The root is 5.
Is 5.
Right?
Yeah, right? Because remember, the bottom number, like the roots of a tree, are on the bottom. Right? So that's going to be our root of this. And then again, you could write it with it all being raised to that 1st power, but of course that's not going to change anything on that. And since x it's not a number inside there, and there's not enough x's to come out, right? Because remember, with 5th roots, you have to have 5 of the same in order for something to come out. Then this one won't simplify anymore, so our answer would just be the 5th root of x. You can just leave your answer that way. Questions so far on what we're doing? So sometimes you'll see on some calculators that you can raise something to a fractional exponent, and so sometimes you can do that rather than writing something in the root form. Okay, so we're going to kind of talk a little bit about that as well. All right, let's try part C here. So what if I had 27, right, y to the 9th power, all raised to the 1/3 power? All right, I want everybody to try this, right? And I want you to put your answer, once you get your answer, put it into the chat box, but don't hit enter yet. I'll tell you when to hit enter. Give me a couple minutes to try that one. Okay, so you should have started off with something like this, but this simplifies more. Right, so we're not going to leave our answer like this. In fact, everything comes out of square roots this time. So in your answer, you shouldn't have any square roots. I'll give you just a few more seconds to finish that up. Make sure you get your answer written in the chat box, but don't hit enter yet. All right, let's see what you got. 3, 2, 1, hit enter. Nobody? Some answers coming in now. Awesome. All right, so remember, just like we did before when we're trying to simplify these radicals, you take that 27 and you're going to break it down to its prime factors, right? So that's 3 times 9, and then 9 breaks down to 3 times 3. So if I was to rewrite this out kind of the long way, that would be 3 times 3 times 3, right, is 27. And then y to the 9th is just 9 of these y's. Right? And so then since it's a cubed root, let me put that cubed root, make sure I don't forget about that guy. Since I have that cubed root, that means things have to come out in groups of 3. So a 3 gets to come out. Right. There's 3 y's, so that gets to come out as a y. Another group of 3 y's. And another group. Right. And so that really is going to be, so for our answer, right, that gives us 3y to the 3rd power. So we should end up with there. And a lot of you, it looks like, came up with that. And there. Any questions about that one, though? If you didn't get that and you're still not understanding what to do there, please speak up and let me know what I can clarify better. All right. Let's look at another one. What about one like this? So let's do negative 25 all raised to the 1/2 power. Right, so again, if we write this as a radical, right, our base this time is negative 25, so that's what's going to go inside. And then we've got our root of 2. So again, like I said, you don't really have to put that 2 there. but sometimes it helps people to remember that that's what you're doing. All right, so you're trying to find the square root of negative 25. But remember we said that we can't find the square root of negative numbers with just the real number system. So we have to use imaginary numbers, right? And so it's going to be really similar to what we did before. So after you change it to radical form, right, I want you to think about, if we broke this down, that breaks down to be negative 1 times 5 times 5, right? Where negative 1, right, comes out, square root of negative 1 is I, and then we've got, a square root, so there's an invisible 2 there, remember, and so we need 2 of the same, so that 5 gets to come out. Okay? So that means our answer in this would just simplify to be 5I. Right? And that I is telling us that there was a negative inside the square root. And that's kind of how we know, about that we had some kind of a negative inside a square root. Okay, so same idea, what we were doing before, so you will see some imaginary numbers sometimes on these, because if we were taking the square root of a negative number, that gives us imaginary solutions. Right? Let's do another one here. How about if we have in parentheses negative 8 y to the 6th power, all raised to the 1/3 power. Right? So since this whole thing, right, this is in parentheses, so this is telling me all of this is being raised to the 1/3 power. If those parentheses weren't there, that would be, meaning that only like y was being raised to that power. Oh goodness, I'm sorry. Been so tired the last few days, so excuse my yawning. All right, so let's write this as a radical. All right, so this time, right, all of this is going to go inside. So negative 8 y to the 6th power, and then we've got a cubed root there. Right? The root on this is 3. Right? And then that 1, remember, is I could raise that whole thing to the 1st power, but like we saw in the first few, it didn't matter. It didn't change anything when we raised everything to the 1st power. All right, so now we're going to do kind of the same thing that we did up there on part C. Okay? So I want everybody to try this one again. So everybody figure out what is the cubed root of negative 8 y to the 6th power. Okay, let me give you just a couple minutes. Try and do that. All right, so I came up with negative 2 y to the 2nd. All right, let's see if that's what you got. If not, let me know what I can help clarify for you there. Remember that you can't take the square root of a negative number, right? That's going to give you imaginary numbers, but you can with a cubed root, right? Because negative, just kind of move this over a little bit more, because remember that if we do negative 2 times negative 2 times negative 2, well, negative 2 times negative 2 is 4, and then if we times that by negative 2, we get negative 8, right? So you can get a negative number when you're multiplying three negatives together. It just doesn't work with, when you're only multiplying two numbers together. Anytime you have a negative times a negative, you'll always get a positive answer, right? Not a negative one. So just make sure that's clear on there, why this one doesn't have imaginary numbers in it, where the one above it did. All right, let's do one more here. Okay, so I want everybody to try and rewrite this one in radical form. So take just a minute, decide how you would put that. Okay, so let's look at what you did here. Now I want you to notice that only x is being raised to the 1/5 power, right? The 7 is not this time, right? That would have to all be, we'd have to have the 7x in parentheses raised to the 1/2 power. So the 7x is not going inside the square or the root on this, right? So 7 is just going to be out in front of our root, and it's being multiplied by the 5th root of x. And then there's nothing more that we can do to simplify that. So that would be our answer there. All right, so notice that that 7 is not inside. Everybody understand why that's not inside this time?
Don't totally understand why you would leave it out.
So what's being raised to the 1/5 power?
The x.
Just the x.
Okay, so they're not connected. Okay.
Right, so we have to kind of think of these guys as two separate things. We've got 7, and then x to the 1/5. Right. So 7 stays on the outside here, and then our x to the 1/5, we're writing that way. Does that make sense? And maybe, because if we compared it to, if it said 7x in parentheses raised to the 1/5, right, that would be the 5th root of 7x, right? Because then we're taking the 5th root of everything. That makes sense? Kind of see the difference there?
Thank you.
Yeah, and this is where it always seems to get tricky on the homework for a lot of people, is because they're thinking this second way when really it's written down in this first way. Right? So just watch that carefully when things are in parentheses and when they aren't. Just like we talked about before, sometimes you got to make sure that you're looking to see when it's in parentheses or not. Remember how we talked about at the beginning of the semester, if we had -2 raised to the 2nd power, right? That's -2 times -2, which gives us +4. But if we have -2 raised to the 2nd power, right? And we said, okay, we really have to think about this as being like -1 times 2 to the 2nd power. So you're just multiplying, you're doing the 2 to the 2nd power, and then timesing that by a -1. So that's how you get -4, right? When it doesn't have the parentheses around it, but you get +4 if it does. Right? The same kind of thing is happening there. Oops. All right. So let's look at some. So all of the ones that we have now, notice that all of the numerators on these, these first few that we did together, all the numerators were 1. Okay, but let's talk about what happens when that numerator is not 1, when we have something different than 1 on that. Okay, so let's do that. These next examples. So for example 2, okay, same kind of instructions that we had before, right? I want you to write using radical notation and simplify if possible. Okay, so for this first one, if we have 9 raised to the 3/2 power, right? So it looks kind of weird in this form, right? Not used to seeing these fractional exponents, but let's take that and write it as a radical, right? So again, we said our 9, right, is going to be inside here. And then our root of 2, right? Remember the bottom number is always going to be our root, right? And think of that as like a tree, right? The roots of a tree are on the bottom. And when we're writing in a radical form, we write the root out here. Okay? And then this is all raised to the 3rd power. Okay, so I'm just trying to point out where that 3 and that 2 go when we write it in radical form. Okay, but let's start on the inside here, right? Let's simplify everything we can on the inside first. So what's the square root of 9? Well, square root of 9 is just 3. And then it says now we need to take 3 and raise it to the 3rd power. Right? So 3 times 3 times 3 is 27. So 9 to the 3/2 power is 27. Okay? It's just another way that we can write that and kind of simplify it. Okay, let's look at another one. How about if we have negative 25 all raised to the 2/5 power? Okay, I want everybody to try this one, right? And then when you get your answer, put your answer in your chat box. So change it to radical form and simplify it. Whoops, did I put 25? I meant to put 32. I don't know what I was, hold on guys, hold on. That's not going to give us a very nice answer. Let's do negative 32. Just mixing two different problems together. Sorry about that. Try that one now. You raise your hand when you have an answer so I can kind of see where people are at, if you've been able to come up with something. You gotta find that participants box and find that hand raise button. your hands up. All right, let's go ahead and have you guys put your answers in the chat box. And then just press enter. 3, 2, 1, hit enter. Okay, interesting. I'm seeing some people coming up with 4 and some people coming up with -4 on this, right? So let's look and see which one is correct, right? So we're going to take and put this into radical form, right? Our root is 5. It's going to go out there. -32 goes on the inside, and then that's going to be all raised to that second power, right? That top number there. So then let's simplify everything inside there, right? Which is going to be a -2, right? If you take -2, raise it to the 5th power, you get -32, right? And if you're not sure, how to do that, I mean, you can use your calculator to help you, figure that out when it's the number part, right? There should be something on your calculator, and I'm not sure if we talked about it before, but there is a button usually that looks kind of like this, right? Where it's kind of like saying the, whatever root you want it to be button. There's a square root on there. There's usually a cubed root, but then there's one that you can just make into a 4th root, a 5th root, 100th root, right? You can make it whatever root you want it to be there. So that's nice. So if you can find that button, and if you use that, right, the 5th root of -32, that's -2. And then we're going to raise that to the 2nd power. Now, why did I put it in parentheses like that? Because I think that's where some people came up with the -4, where other people came up with the 4, right? Kind of like just got done talking about up here, right? Well, notice that it was in parentheses, right, before here. And so I need to keep those parentheses on it, because whatever answer I get there needs to stay in parentheses, and then I'll square that. All right, so that is saying -2 times -2, which gives me a +4. Does that make sense? As we're doing really good, I could tell, you were like on the right track there, but it's just that difference between seeing, is it 4 or is it -4, right? And there's quite a few people that put -4 as the answer. So,
I have a question.
yeah.
So I pulled out an I, and I got 2I, and then I squared 2 and I, and that's why I got -4.
But you can't pull out an I on this because it's not an even root.
Oh.
Right? So if the bottom was either 2 or 4 or 6 or something like that, right, we'd have to pull out an I. But we can't, because we can figure out the 5th root of -32, right? Because if you tried on your calculator to do like, the square root of -25, it usually says like error or something like that. But if you put in the 5th root of -32, it's going to give you -2 as your answer. Does that make sense?
Yeah, it makes a lot more sense now.
Okay, cool. No, I'm glad you asked that. That's a really good question. I think sometimes it gets confusing going, okay, when am I using those I's, right? And it's just when we have even roots. Okay? Because remember, there's not 2 numbers that we could multiply together to give us, like up on the one that we did before, like this. Just kind of show here, right? So this one we had to use imaginary numbers because we were thinking of what times what that's the same number would give us negative 25. There's not, we can't do negative 5 times negative 5 because that gives us positive 25. We can't make one of them positive because then they're not both the same number, right? So there's nothing, no two numbers that could multiply together to give us a negative 25. We're down on the other one that we did. There is, right? If we take negative 2 times negative 2 times negative 2 times negative 2 times negative 2, we do get negative 32. Okay. Good questions and comments there. I like that. All right. Like understanding what something is not helps you understand what it is too, right? So trying to look at it in both of those ways is really a good idea. All right, let's take a look at the next one. Then, okay. Was there another question though that anybody had? Okay. All right, well, let's look at part C on this one. Okay, let's see what we can do here. So on this one, if we have 1/4 raised to the 3/2 power. Okay, and I know, like, right off, like, I think some students look at this and, like, you guys aren't even here with me, and I can already feel, like, the anxiety, like, people are like, what? I've got this fraction raised to a fraction. This looks scary, right? But just try and break it down and be like, okay, but remember that fraction on the outside is just a root. So I'm just going to change it to root form, right? So let's do that. So square root, right? So that 2 goes out here. The 1/4 is what goes inside, and then the whole thing is being raised to that 3rd power. Right? So first of all, make sure that you're understanding that you're seeing what we need to do there. Okay. Then you need to find the square root of 1/4. And you could do that on your calculator too, if it's, if you want to do that, your calculator will do it. And it doesn't really matter if you have it as a fraction or if you change it to a decimal. I don't really care. On the homework, it might want you to keep it in fraction form, but if it's not a, if it's a terminating decimal, then it probably wouldn't matter. They're not going to mark off of that either, I don't think. But so let's look at this though. The square root of 1/4. I want you to remember that we said before when we were talking about radicals, that if it was connected by division, we could separate these two things out. So I'm doing the square root of 1 over the square root of 4. And then when I do that, I'll raise everything inside to that 3rd power. Right? So it makes it a little bit easier to see if I put those on saying, okay, I'm taking the square root of each of those separately. So the square root of 1 is just 1. The square root of 4 is 2. And then I'm going to raise that all to the 3rd power. Remember, our property of exponents said we have to give, everybody inside that power of 3. So that would be 1 to the 3rd power over 2 to the 3rd power, which just gives me 1/8 for my answer. Okay, please speak up if you have some questions. Right? Please know you're not going to be the only one with that same question, and you're going to be helping by asking your questions. It's so hard for me to read you guys in the silence. Right? All right, let's do one more here on this type. What if we have in parentheses 2x plus 1 all raised to the 2/7 power. Right? So notice everything is in parentheses there. So that means the whole thing is inside that root, right? That 2x plus 1 is inside that root. Well, what root is it? Well, it's a root of 7. All right, just remember that idea of a tree, right? Roots of a tree are at the bottom. All right, so that is the root of our radical, and then that's all going to be raised to the 2nd power. Okay? And that would be done. Remember, this could be written, I'm going to write it the other way so you can kind of see. It might make a little bit more sense on this one. So remember how I said, let me go back up to where we talked about kind of the definition of this. I've been simplifying it in, this way mostly, because oftentimes this is going to be the easiest way to simplify it. You could do it the other way, but what happens here is oftentimes like you're making that number even bigger that's inside the radical, and then you'd have to find the square root or 5th root or whatever, what kind of root it is. And, and it's just easier for me to find, the radicals of those numbers when they're smaller. So that's why I choose a lot of times to do it this way, right? But on this other one, I want to show you what happens if we do it the other way, right? What we can do here. So this could also be written as, right, the 7th root of 2x plus 1 all squared, right? So it could be written that way as well. And then again, that's all we could do with it, right? So it doesn't matter which way you write it, right? Either way is going to, you're going to get the correct answer there. And there's no way we can simplify this anymore. I mean, if you wanted to square this out, you could like FOIL those together and stuff, but you're still not going to be able to find the 7th root of all of this because of, the x's and stuff that are going to be in there. So don't overthink ones like this. If it's just like that whole thing raised to the 2/7 power, just remember, okay, that's my root. The number on the top is my number on the outside. Okay. All right, let's go on to example 3, but please speak up. Please, please, please. Okay, so again, so this time we're going to go the other way. All right, I'm going to give it to you in radical form, and you're going to change it to fractional exponents. Okay, so I'm just going to say right, using fractional, right, or sometimes they'll use the word rational. We use that a lot. Fractional exponents. And then simplify if possible. All right, so let's see what we have here on this one. So what if I have the 8th root, right, the 8th root of x to the 3rd power? Okay, so I just want you to change that to fractional exponents. So you should have gotten x to the 3/8 power. All right, remember whatever our root is our bottom number. All right, and then that's all we can do. There's nothing we can simplify on that one. That one is done. Okay, how about this one? What if we have 4 times the 6th root of k squared? Okay, so I want you to notice what stuff is inside the radical. I'll give you just a minute to try that one. sometimes it's just going to take some practice with these. So. Okay, on this one, so notice the 4 is not inside the radical, so it's just going to stay on the outside, right, of our answer. It's not going to be inside, it's not going to be raised to a fractional exponent, just the k is. All right, so 4 times k to the 2/6 power. Okay. And then notice that this fraction can be reduced. And so part of this simplifying when it's in this form is to make sure that you reduce any fractional exponents that you might have, right? So that really is going to be 4 times k to the 1/3 power, right? And remember, it's just the k that's being raised to that 1/3 power. Questions on that one? Let's try another one. How about if we have the cubed root of x to the 4th times y to the 6th. Okay, so on this one, remember, like we talked about before, when things were connected by division, we could separate those out into separate radicals. And also when they're connected by multiplication, we can do that. So I'm going to do that on this just to help clarify maybe something a little bit more. Some people choose to just kind of do it in their head from here, but I hope this will help clarify a little bit more here. All right, so I'm going to take and, do each different part, right, raised, to that, or having that, the radical of 3 there, right, that cubed root. And then if I'm looking at each of these, right, so let's just look at this first one here. Well, the 3rd root of x to the 4th is written as x to the 4/3 power. Right, and then we'd want to look and see, can we reduce that 4/3? Nope, so that looks done. Right, what about the other one? Right, this would be y to the 6/3 power. All right, now 6/3 can reduce. 6 divided by 3 is 2. So we really want to take that one more step and simplify that to be y squared. All right, so our answer would be that. How about questions on that one? I'm feeling so useless. Can't even answer any questions for you guys. Okay, well, let me see by raise of hands. I just want to see kind of where you guys are, feeling about this, right? So on a scale from 1 to 10, with 10 being, I feel like I've got this down pretty well. Like, 10 is going to be like the best, right? I've got this down. And 1 is, I don't understand a thing you're doing, Becky. This isn't making any sense to me. Okay. And if you want to just remember, you can private message it to me. This doesn't have to be something that you say to everybody. Just go to the chat, and where that drop down is where it says everyone. You can message the host privately, so you could do that. Okay, but I want everybody to put that in the chat box for me. Let me know where you're feeling like you're at on a scale from 1 to 10. 10 being, I've got this, Becky. 1 being, I'm so lost. Okay. So go ahead and type those in. Like I said, just send it to me privately if you want. I want to see an answer from everyone. Okay, there's still a few of you that still need to comment. Everybody go to the chat box. Put in from 1 to 10. 10 being you got this, 1 being I am so lost. It looks like most of you, everybody commented. It's like a 5 or above, so that's good. But those of you that are, feeling about the 5 area, right? Is there anything that I could answer for you or help clarify for you more? Or do you think you just need a little bit more practice with it? What are you thinking there I can help you with?
One thing that confuses me is like all these fractions in different numbers.
Uh-huh.
So like I know you got 3 8s because obviously the numbers were, the 3 and the 8, but like how did you get like the 6 and then the K and the 2?
So on the, so maybe let me try and
Part
do,
B.
on part B. So let me maybe make these into some different colors here, right? So if I said this is, so this is what was given to you, right? So this is your question, 4 times the 6th root of k squared, right? So I'm going to take that, whatever number is being raised to the power on the k, that's going to be your top part of the fraction. And then whatever root you have is going to be the bottom part of your fraction.
Okay, thank you.
And then just simply, then just reduce that, right? So you're thinking, okay, I've got 2/6, right? And so then you just need to reduce that fraction. 2 goes into 2 once and into 6 3 times. So that's where I got that 1/3 from, right? Just kind of reducing those fractions. And then that 4 we're not doing anything with. It's just, it's just hanging out outside, right? Just being multiplied by other stuff. Does that help?
Yes, thank you.
Yeah, you bet. What other things? Anyone else think of any other places where you're kind of like, I'm not sure what you did there, Becky? Okay, so wanted to make sure you're kind of feeling good about this or get questions answered about this part, right? Because remember, just like we did before with properties of exponents, we had some negative exponents, and those are also going to pop up in these as well, right? So if you're feeling really like your anxiety just went up, you're like, what, Becky? We're dealing with fractions and negative exponents, right? Take a deep breath, okay? Because you can do this. And really, it's trying to not look, just kind of trying to look one step at a time. And it really helps a lot. Just to relate it to something in real life, like I used to run a lot. And whenever I was running up hills, if I tried to, if I was looking up the hill and I was just seeing just the end, from where I was at to the end, I would always be like, I can't do this. There's no way I can make it up this hill, right? But I found that if I look just a couple of feet in front of me, then it didn't seem so overwhelming. And so I tell students to kind of think of it, that way too. So just focus on what is your next step. Okay, what is my first step? Try and break it down into smaller things. And when you're feeling overwhelmed by it because it can feel overwhelming, you know, at times when you're looking at this, and then all this negative stuff starts going on in your head, and you know, and you don't want that in there, right? I know you guys can do this, and you can stay positive about it. Okay. All right, so let's look at this one. See how you do here, right? So write with positive exponents. Okay. Then simplify. Okay, so first one, I'm going to have 27 to the negative 2/3 power. Okay, so remember that when we have a negative exponent, right? So put this over here, negative exponents. Right? Oops. Want to be flipped. Right? Remember, like we talked about, like, you know, we're talking about the upstairs and the downstairs, right? Where are you going to flip it to? Okay. And so think about, so let me, I guess maybe before we do this one, let's look at one over here. So if I just had 27 to the negative 2 power, right? This was kind of what we did before. I didn't have the fraction part, but I want to relate it to you without the fraction, right? We just said, okay, 27 to the negative 2 power. We think, okay, well, I can put a 1 underneath that, and then I'm just flipping it. So 1's on the top, and then 27 to the second power, right, is now on the bottom. That negative exponent now became positive. All right, and I'm not going to figure out what 27 to the negative or to the second power is, but if we just left it like that, right, now it's a positive exponent. Okay, so same kind of thing is happening here, right? But now we have this, it's just a fraction instead. So I want you to think of, okay, I'm going to put a 1 underneath this, right? When I flip it, I'm going to have 1 on the top, and I'm going to have 27 to the 2/3 power on the bottom. Right? All that changed is that negative exponent is now a positive exponent, just like we did over here when it wasn't a fraction. Right? But that fraction, notice that that fraction's not flipping, right, as the exponent. That exponent is staying 2/3. Right? The only thing that is flipping, remember, is that, you know, that 27, the base number, is what's flipping. Okay? All right, and then we can simplify this more. So I'm going to rewrite this. Maybe I'll put these things in again too. If I have, so I'm going to say to the 2/3 power like this, right? Just to help you see where things are going. So 1 is on the top, and on the bottom I've got 27 inside there, right? That's my base. My root is 3, so that's the number that goes on the root of my index, and then that's all going to be raised, right? This whole bottom is going to be raised to the second power. Okay, before I simplify this any further, okay, what questions do you have to this point? We're not done yet, but I just want to make sure I'm answering any questions you have here. Okay, so let's look at, so if we simplify this more, right, 1 is still on the top. The cubed root of 27, and like I said, you can do that on your calculator. Does everybody see how to do that on your calculator? I mean, most of the numbers are going to be such that, you know, you might know some of these, but if you don't, that's fine, right? I mean, I said, you know, it'd be a good idea to, memorize some perfect squares and some perfect cubes. It's when it gets into the fourth and fifth roots sometimes that we're like, I don't know, So don't be afraid to use that calculator if that helps you. So the third root of 27 is 3, and then we still need to square it, right? Haven't squared it yet. All I did was simplify the stuff inside, right? Then I still have 1 on the top, right? And then I have my, did I write that all down right? Yeah, so that's 3 squared, and that's going to give me 9. Right? So 1/9 be my answer there. Okay. What else can I clarify better on that one? Okay, I'm going to have you guys try this next one. I want you to write your answer in the chat box after you get it. Remember, you can just message it to me privately, okay? If you're feeling self-conscious and you don't want to put it in to everybody, it's okay. It just kind of helps me to know where everybody's at, what they're understanding, or what common mistakes you guys might be making, right? Because if you're missing it, I can say, oh, they were thinking we had to do this instead of that. And so that can help me clarify some things too. Okay, so on this next one, I'm going to give you a few minutes. I want you to try it, get it all simplified up and everything, and then put your answer in the chat box. But don't hit enter until I tell you, because sometimes people see those answers in there and then they stop thinking about what they were doing. All right, so let's do 256 raised to the negative 3/4 power. Okay, so let me give you a few minutes. If you're sending it to me privately, you can just send it as soon as you put it in to the chat box. me see what you guys have come up with. I'll give you just another second. Get your answer put inside the chat box. If you have it done, but you didn't put it in there yet. Okay, and then 3, 2, 1, hit enter. Wow, so awesome. Look at you guys. Right? 1 over 64 is exactly right. Right? You guys got this. So remember, let me just work through it because not everybody answered there. So I'm not sure if some people got stuck. Right? So let's look and see. Remember that 1 is going to go on the top, and we're flipping that negative exponent right downstairs. And so we've got 256 raised to the 3/4 power. Right? And so that's going to give us, we write it as a radical. Right? We've got 256 inside there, but we want to make sure that we're doing the 4th root, right, of 256. And then when you do that, then take that answer and raise it to the 3rd power. Okay. So the 4th root of 256 is 4. And then we still need to raise that to the 3rd power. Okay. And then when we do that, we get 1 over 4 times 4 times 4 is 64. So 1 over 64 is your answer. Okay, so even though it might look a little, crazy starting off with and stuff with those negative exponents and everything, right? With their fractional negative exponents, I should say, just break it down step by step. You guys can do this. Okay. All right. I think we should take a little break right there. It's about that time in our class, so let's take a little 5-minute break or so, and then we'll come back and we'll still keep talking, have more to talk about with these with these fractional exponents. Okay. right, let's get back in here, and might be finishing this up a little. We might finish up a little bit earlier today, but that might be good because some of you, I'm sure, would like to get the test and stuff taken. Remember that this 12.1, the stuff we're talking about today, will not be on exam 3, right? It's going to be on the final exam, so you need to know it for that, all right? But remember everything, you know, up through the module 10 stuff that we talked about, things that we talked about last time will be on the module, or sorry, the exam 3, but starting today, this stuff you'll just see on the final exam. Okay, so remember that the exam 3 is available for you to be able to take now too, and so just make sure that if you're writing it out on a separate sheet of paper, that's totally fine with me, but just make sure it's very legible, right? And make sure you're boxing or circling those answers to make it easier for me to find them. We'll just be really appreciated if you do that. Okay, and you can use your scientific calculator on these as well. Just make sure you're showing all your work, and so I can kind of see what your thought process was, what your ideas were. Okay. All right. Well, let's continue back into this. So, example 5. Okay, this is where we're going to use some of those properties of exponents. And maybe I'll put some of them over here again just to remind you. Remember our property of exponents said, like, if we had a to the m power times a to the n power, right, when it's connected by multiply, we add those exponents together, right? If they're connected by division, then we subtract the exponents. And if it was a power raised to a power, so a to the m all raised to the n, right, like that, then we multiply those exponents together. So a to the m times n power, right? We already talked about that negative exponent one and how that works, but remember that, you know, a to the negative m power is the same thing as 1 over a to the m. And if you have something raised to a 0 power, right, that's always 1. Right, and then there were a couple more on there about distributing, you know, through. Right, so if you had a times b all raised to the m power, that would be a to the m times b to the m, right? Give everybody that exponent. And that also happens when you're dealing with division. If you had a over b, right, raised to the m power, make sure you're giving that that exponent to everybody inside. Okay, so these are kind of some of the properties of exponents that we talked about that you're going to be using again today. All right, so making sure that you have these down really well for the final exam is going to be really important. Okay. All right, so let's look at some of these. So if I have, so let's do part A. I'm going to do b to the 1/3 power times b to the 1/4 power. Right, so remember that since it's connected by multiplication, then that means we're going to add those exponents together. Right? So I'll get b to the 1/3 plus 1/4. Right? But now we've got to remember with fractions, right? So we're kind of having to remember, okay, I've got these properties of exponents, but I also have to make sure that I'm following my fraction rules. So whenever I'm adding fractions together, I've got to get a common denominator, right? So common denominator between 3 and 4 is 12. So I'd rewrite that as blank over 12 plus blank over 12. Right? And so I'd be multiplying this one by 4. 4 times 3 gives me 12, so I'll multiply by 4 on the top also. All right, so I get 4/12 there. All right, on the other exponent, I have 4. I need to get it to a denominator of 12, so I'm going to multiply by 3. 4 times 3 is 12, so I need to multiply the top by 3 also. All right? And now that I have a common denominator, now I can add those exponents together. So I'll get 7/12. So b to the 7/12 power would be my answer there. All right, so see how it's like so you're using the properties of exponents, but in addition, you also have to remember your, properties that we have when we're adding fractions, multiplying fractions, subtracting fractions. All of those are going to come into play. Okay, and like I said, you do have calculators, and some of your calculators will, do some of this for you and things, but I do want to still see some work, right? I want to see what you're coming up with and how you're doing that, just to make sure you see that process of what's happening here. All right, so what about part B? So if I have 9 to the 2/5 power divided by 9 to the 12/5 power. Right. So we've got the same base, and so we need to subtract those exponents. All right, so we write it down this way. So we've got 9, and we're always doing the top exponent, right? So that 2/5 minus the 12/5. I'm going to do the top minus the bottom. All right, so when we do that, we already have a common denominator. How nice, right? We don't have to go and find it and do that. So I'm just going to get -10. 2 minus 12 is -10. And then I keep that the same, right? It's just 5. But then I need to look at this and say, oh, this can reduce further, right? And I want to look up here, and I didn't mention it. I did it in my head, but I, thought, can 7/12 reduce any further? And it can't. But if it did, I'd want to reduce that more, right? This one does. -10 divided by 5 is -10 divided by 5 is -2, so 9 to the -2 power. All right, so now we're dealing with these negative exponents, but you need to make sure that all of your answers always have positive exponents. So that means this one's got to flip. So we're going to be 1 over 9 squared, which is 1 over 81. All right, let me clarify anything for you on that. Questions that you have on those two. This part A and B. Okay, so these properties of exponents are definitely something that you want to have down. And remember how I said in class next week, I'm going to talk about kind of, maybe a sheet of paper that you should get together, because you have to have your, your own notes and stuff on this, or anything that you've written down. But if I were you, I would make up, even if it's 1 sheet or 2 sheets of paper with all this, important information that you need to know, formulas that you might need to have memorized, these properties of exponents, or different things about, linear functions and quadratic functions and exponential functions, right? Get those all together kind of on 1 sheet of paper. That really will help a lot when you have, a time limit on this test to get through what you need to get through, okay? But we'll talk about some of those things that you should get together on a sheet of paper next week. All right, let's do part C. So let's try this one. I want everybody to try it, and then I want you to put your answer in the chat box. Don't hit enter yet, but try this one. Okay, so simplify that. Y to the -3/10 power times y to the 6/10 power. Okay, so in this one, right, you should have used that first property that we talked about. So you're doing y to the negative 3/10 power, right, plus 6/10 power. All right, so always going to have you guys press enter. Did you guys put it in there, what you came up with? Okay, go ahead and hit enter now. 3, 2, 1, enter. Put that in. What do we come up with here? Awesome. So most of you are saying y to the 3/10 power, right? Negative 3 plus 6 is positive 3. And then there's nothing more that you can do to simplify it. So you're going to be done at that point. All right. All right. Look at just a few more here. You guys are doing awesome on this. Okay, just keep reminding yourself how awesome you are. Okay, so this time we have a power raised to a power, right? So that means we need to do some multiplication. So I'm going to write it out this way. I've got 11 raised to the 2/9 power, but then I need to multiply that by 3, but I could write that as 3/1, right? Write it as a fraction, because remember, when we're multiplying fractions, we multiply across the top and multiply across the bottom. Right, so that's going to give us 11 to the 6/9 power, and then that 6/9 can be reduced, so we'd want to reduce that. All right, 3 divides into both of those, so that would be 11 to the 2/3 power. Right. And you'd be taking the, if you tried to change it to a radical to simplify it further, right, we wouldn't be able to do anything with that 11, right? The third root of 11 is not a whole number, right? It's going to be a decimal number. Okay, so that would be your answer. Okay. All right, let's look at this one now. What if I have, so I'm going to have this one's going to have a fraction, okay, on the top. In parentheses, I'm going to have x to the 7th power times y to the 2nd power, whoops, that, all raised to the 1/6 power. Whoa, right? And then on the bottom, we're going to have x to the 1/24 power times y to the 7/24 power. Right, this one. Sometimes it's hard to make sure that those powers are looking like powers because that fraction gets so big sometimes there. So I'm trying to move it down a little bit. Okay, so let's just start on the top, right? This is saying that we need to distribute that 1/6 power through to everybody. So I'm multiplying those, right? So I'm having x to the 7th power times the 1/6 power, right? And you could probably, some of you will be able to do this in your head. I'm just writing it down to make sure everybody's together here. Y to the 2nd power, and I'm going to write that as 2/1 times 1/6. Right, and I'm just going to keep going on the top here for a second. So I've got x to the 7/6 power, and then y to the 2/6 power. Okay. Let's go to the bottom now, because I can't combine my x's and y's together anymore, right? They're different bases. So let's go and see what else we've got here, right? And so I do have this x to the 1/24 power and y to the 7/24 power. And I can see that I have some things that I need to combine together, right? So I need to get these x's together, and I need to get these y's together, right? So I am going to be subtracting those, but I can see already, right, because I need to subtract, I need a common denominator. And so if I'm looking for my common denominator for the x's, right, I've got 6 and 24, so 24 would be my common denominator there. Right, so let's see if I can try and write this out over here. Right, so we're doing x to the 7/6, right, minus 1/24. Right, I'm subtracting those. And then I've got y to the 2/6 minus 7/24. Right, but I've got to get those denominators the same. So we said 24 is common denominator there. So let's try, I'm going to go just underneath here. I might make it a little bit easier. So I've got x to the blank over 24 minus blank over 24. Well, this second fraction was already 24, so we know that's going to stay as 1/24. But this first one, right, was 6, so we had to think, okay, 4 times 6 gives me 24, so I've got to do the 4 times 7 on the top, so that will give me 28. Okay, let's do the y part now. So again, 24 is my common denominator there. Okay, and I need to multiply by 4. So that'll give me 8 on the top. But then my 7 was already there. I don't need to change that one, right, because it was already 7/24. Right, so now let's just combine these beauties together, right? So we get x to the 28 minus 1, so there's 27 over 24. And then y to the 1 over 24. Right, and then I'd want to look and see if there's anything I could reduce, and there's not. So that would be my answer. Okay, that one had quite a few steps. Right, so what things can I clarify better on those steps? And if you find I'm going too fast, please just say, Becky, will you slow down a little bit? Because like I said, it's hard for me because I can't see like what you guys are doing or your body language or anything like that. And I'm so used to seeing that, being able to tell, okay, do I need to slow down or speed up or what? I can't tell. All right, so a lot of different steps on that one. But again, right, think about how you're just going to look. Right, what is our first step? Okay, what is our next step? Right, try not to get overwhelmed with the whole process, but just take it step by step. Okay. All right, let's see. I think we'll do 2 more here. And then I'm gonna look at some of the ones off of your homework too, because I do want to make sure we kind of look at some things there. Okay, so in parentheses, I'm going to have a to the negative 1/3 power, b to the 2/5 power, and then they're all going to be raised to the 1/4 power. Okay. So again, we've got a power raised to a power, right? Which means we've got to multiply those together. So you could start, remember, there's more than one right place you can start on this. We could have flipped that a, we could flip the a to the bottom first because we can see that it's negative, right? But then we'd still have to make sure that we raise it to that 1/4 power. But I think usually it's going to be best so you don't forget to raise to that 1/4 power to just distribute that 1/4 power through first. Okay, so we'd have a to the negative 1/3 times 1/4. Right, we're multiplying those together. B to the 2/5 times 1/4. All right, and then let's simplify this more. So we've got a to the negative 1/12. All right, just multiplying across the top, multiplying across the bottom, and then b to the 2/20. All right, so I've got A is unhappy upstairs, so we want to make sure to flip A downstairs, right? Remember, that doesn't flip our exponent. It just flips the whole A downstairs, right? So we'd have A now to the positive 1/12 power. All right, we flipped it to make this a positive. All right, we need it to be a positive exponent. And then B to the 2/20 power is perfectly happy up top. Okay, but 2 over 20 can reduce, so let's reduce that. That'll be B to the 1/10 power over A to the 1/12 power. Right, and we can't combine those anymore together because we have different bases. We've got a B, we've got an A. So that will be all we can do there. Questions on that one? Let's look at part G. All right, so this one says it's going to be a fraction again. And I've got 27 A to the negative 1/2 power, all raised to the negative 2/3 power. All right, and then on the bottom, I've got A to the 5/24 power. All right, so a couple things here that I want to make sure that you're seeing, right? Remember that this 27 and this A to the negative 1/2 are different, right? And if it helps you to put like a little multiplication dot in between there to kind of see them as different things, then that would be a good idea to do. Because remember, we've got to raise the 27 to the negative 2/3 power and then the A also to that power, right? So I'm going to have 27 to the negative 2/3 power, all right, because its power on it right now is just 1, all right? So 1 times negative 2/3 is just 2/3. And then here, I've got A to the negative 1/2 times negative 2/3. And then I still have that A to the 5/24 power. Okay, let's simplify more on the top here. So looking at this, right, that negative exponent means it wants to go downstairs. So let's move this guy, right, wants to go downstairs. Let's put it downstairs, and that will be 27 to the 2/3 power. All right, so it just changes from a positive 2/3 to negative 2/3 to a positive 2/3 when it moves down there. All right, and then we still have that A to the 5/24 that's down there, and perfectly happy down there. It's not negative, so it's going to stay. All right, now let's multiply those powers together on A that we have on the top. So we've got A to the negative 1 times negative 2 is positive 2 over 2 times 3, which is 6. Right? And now, right, I need to look and see, okay, I've got to simplify my 27 more, but I also need to get my A's together, right, by doing some subtracting there. And it doesn't matter which one you do first, but let's look at these A's. I'm just going to kind of circle these so we can kind of see I'm trying to put these guys together, right? So when I do that, I'm doing A to the 2/6 power minus 5/24. Right? I've got to subtract those because they're connected by division. And I need to get a common denominator now. Right? So A to the blank over 24, blank over 24, right? We times this by 4, and we get 8 on the top there. Right? And then I still have that on the bottom here. Right? I still have that 27 to the 2/3 power, but I want to change that to a radical, right? Because that's going to help me simplify that a little bit more. So I have, so 27 goes inside, right? And then if I have like, so 2, right? So the whole thing is being raised to, but then 3, let's see, numbers I haven't used there, or pictures, or colors. Let's try and talk here. All right, so that's our cubed root. So we're doing cubed root of 27, and then we'll square it. Well, cubed root of 27 is 3, and then 3 squared is going to give us 9. Okay, and now we just need to subtract the rest of those on the top. So a to the 3 over 24 power, but then that can still reduce. Right? Make sure that 9 doesn't look like an A. When I looked at those, I was like, oh, wait a minute. They're not the same. Right? So I've got a to the 1/8 power. I reduce that. 3 goes into 3 once. 3 goes into 24 8 times. And then I still have 9 left on the bottom. Okay. So I realized that one, there's a lot of steps on that. There was a lot to simplify there. But again, I just took it one step at a time, kind of thought, okay, what do I need to do first? All right, I'm going to distribute that power to everybody, right? And then just try and go from there, one step at a time and simplify it. What can I answer there, clarify for anybody on part G? You guys are like more quiet than usual today. Are you like most of you half asleep? Or is it because I haven't sang to you yet today? I know, you miss my singing. It's got to be what it is. All right. I know there's a lot to this, but really, right, with anything that you do in math, if you're practicing it, it's going to get a little bit easier the more you do the practicing. So let's look at some off of your homework, because I do want to clarify the way you need to put some of these in, and also it might help what's going on here. Let's see. All right, so I wanted to let's look at number 1 first. And put these side by side so you can see it, but then we can also work it out on the little whiteboard here. Okay, so it says on here, right, for this question number 1, right, it wants you to simplify this, but when you're simplifying it, right, it looks a little bit kind of strange, right, because of what they're saying here. So I want to talk about this. So it says this, C, actually I'm going to use some different colors here. So C times X to the E power. Right? And so they're saying, they want you to simplify it. It's going to look like this form. C is that coefficient. So whatever number is going to be out in front, like 27 is a coefficient on this one, right? And then E just represents what the exponent is going to be there. Okay? And so on this first one, trying to ease you in, this is kind of just going back to what we talked about before. There's no fractional exponents on this one, right? But let's look at it and do this one together to make sure you see what you need to put in these blanks. All right, so if I have x to the 7th, let's see. over 1 on the homework. So x to the 7th times 2x all raised to the 7th over x to the 5th. All right, so let's think about those properties of exponents, right? I've got a power raised to a power here, right? I've got to distribute that power of 7 to both guys inside. Remember that they are two separate things, right? And each of them, they're going to get jealous if one gets a cookie and the other one doesn't, right? So we got to give everybody. Cookie in this is a 7, power of 7, okay? All right, so let's write that down. So then we've got, so we still have that x to the 7th, that didn't change. But now we have 2 to the 7th, right, times x to the 7th. Right, so we've got those all multiplied together on the top. Then on the bottom, we have x to the 5th. Okay, now let's just get our x's together, right? So maybe on top, we can kind of see, you know, this, that we want to do x to the 7th times x to the 7th is x to the 14th, right? And then we still have that x to the 5th downstairs, right? But we've got this 2 to the 7th that we also need to put there, and that's going to be our coefficient. Okay, I think that's 128, 2 to the 7th power, but that's not one that I use a lot. Yeah. Okay, so that's going to be, so 2 to the 7th power, I'll do it like this. All right, so you can see, so that, right, is going to be that 128. Right? But I'm not quite done yet because my x's still are in two different places, right? So I've got to get my x's together. Right? And so since it's, you know, connected by division, I need to subtract those. So I get 128 x to the 14 minus 5 power, right? Right, so that's going to be to the 9th power. And then that's all we can do, right? So that's our answer, but notice that they're not having you put it that way in there. And so this is what I really wanted to make sure was clear to you on these. All right, so in that first blank where it says C is, right? So C is, and then it gives you a blank, and then it says the exponent E is, and then it gives you a blank for that, right? So C is going to be that 128, and then E, the exponent on our x there, is going to be 9. So that's how you'll put those answers in. Okay, so I know it might look a little bit weird, but it's just, I'm sure it was just a programming thing, being able to try and make sure that you write it in there in such a way that they'll mark it right, you know, when it's right, because sometimes when people try and put that 128x to the 9th, especially when we're getting into these ones with fractional exponents, it gets really tricky on how to put those in correctly. So this kind of takes that out of there. You don't have to worry about that. Okay. All right. Let's look at a couple more here. What is this? No. Let's look at number 5 next. Okay, so number 5. All right. So this time we've got the 5th root, right, of x to the 5th power, and then y to the 2nd power. Right? And notice again, these guys are separate from each other, right? We've got an x to the 5th, and we've got a y to the 2nd, right? Put that little, you know, multiplication dot in between there if you think that's going to help you. So really we can separate these out to say the 5th root of x to the fifth and the fifth root of y to the second. Okay, and then it wants you, we're going to write these in rational exponents, right? So notice how it's showing you over here, x to the r power, y to the s power. And so they're just saying, okay, what's the exponent on x and what's the exponent on y, right? So when we're looking at this is x to the 5/5 power, and then y to the 2/5 power. Remember, our 5 is our root. It goes on the bottom in there. But then 5/5 is just the same thing as 1. So I've got x and then y to the 2/5. Okay. So what am I going to put in for my blank on that top one?
Would it be 1?
Yeah, it's going to be 1. Do you see how, even though we don't usually put that 1 there, you've got to make sure that when you're saying your answer here, you want to put that in as a 1. And then you're just going to put your 2/5 in for that bottom one. So just use that little, just that little slash for your fraction bar, and that will be good there. Okay. And then, boom. Yay, I did it right. Okay. Let's look at one more. I'm going to look at number 10 also. Doesn't seem like the one I wanted to look at. I think we pretty much covered everything on there. So just make sure, like when you're writing, this in on something like this, you're just writing it as a fraction. M is going to be a fraction. But, that's all you have to do. And just be careful, right, that you're writing it as like 9/8, not 8/9. You got to remember which one goes on the bottom and which one goes on the top. Okay. All right. And then remember also that I did post a video of the review that we did yesterday. So if you weren't able to attend the review for exam number 3, I would suggest that you go on there and kind of look at some of those, especially on the ones in the review that you're like, ooh, I'm not sure how to do these, right? You can kind of skip through and get down the ones you need to know. And then there's other ones in there. I didn't do all the different parts. There's like A, B, C, D, and some of the questions. I just did a couple of them and left a couple of them for you to do to make sure that you knew how to do those. And to find that review, remember that it is on the just our homepage of Canvas, and then there's the solutions on there also, so you can check and make sure that you're doing those correctly. Okay. All right, any questions? Oh, Luciana, what do you mean? You're math sleeping. You're sleep mathing, I mean. I know. I kind of feel like in a little daze. Is that what you kind of mean?